Hello everyone. This is a solution to problem 9 from my spring 2020 final exam. And in problem 9, in fact this is just part A of problem 9, we'll also have videos for parts B and C. But in all of these problems we're going to be given some infinite series and we want to determine whether or not the series converges or diverges. We're also going to find out for one of them that converges, we can actually compute the value. Generally speaking, right, the ones you're going to be able to actually compute the value of the series are going to be the geometric series. Although stuff from later on in the course, particularly things like Fourier series, will allow us to actually compute some of these things. But for the purposes of this exam, we're really going to focus on only the ones with geometric series and what they converge to. Let's take a look at this particular series. The first thing I notice is that I have factorials. Factorials always make me think of the ratio test. Fine. Well, let's see what I have. I have a factorial squared, and then I have double n factorial. They're both growing very, very quickly to infinity, and it's just a matter of who's going to win out, the n factorial squared or the 2n factorial. All right, so let's try this ratio test. So for the ratio test, I'm going to have to compute the limit as n goes to infinity of, well, okay, normally I'd write the absolute value here, but everything we see is positive, so the absolute value won't matter. I'm going to write the n plus first term divided by the nth term. So the n plus first term is going to be n plus 1 factorial quantity squared divided by, and this is where people are likely to make a mistake. They want to write 2n plus 1, which depending on where you write parentheses is either perfectly correct or absolutely incorrect. So remember, we're replacing the n by n plus 1, not 2n by 2n plus 1, right? We're replacing n by n plus 1. So I'm going to use parentheses to make this clearer. I replace my n by n plus 1. And then that whole expression gets a factorial. All right. Then I need to divide this by the nth term, or if you like, multiply by the reciprocal of the nth term. So I'll have 2n factorial divided by n factorial quantity squared. Okay, so this is now going to be a matter of simplification, understanding how factorials work. So let's say start with this 2n and this 2n plus 1 factorial. So we know 2n factorial is a product of all of the numbers from 1 up to 2n. Whereas 2 times n plus 1, well, we could simplify this, or at least distribute it as 2n plus 2. So this will be all of the numbers multiplied from 1 up through 2n plus 2. So we get up to 2n on the top, we get up to 2n plus 2 on the bottom. In total, we're going to get cancellation of everything except for the 2n plus 2 and the 2n plus 1 terms. Okay, so there's 2n plus 1 and 2n plus 2. Okay, how about these n factorial squared and n plus 1 factorial squared? So I can think of n factorial squared as n factorial times n factorial. All right, so think of this as n factorial and n factorial. And then similarly, I can think of n plus 1 factorial squared as n plus 1 factorial times n plus 1 factorial. And now I'm just going to compare these sort of piece by piece. N plus 1 factorial, right? That you multiply from 1 through n plus 1. N factorial, you multiply from 1 through n. So I'm going to get cancellation here, and the only thing left will be an n plus 1. But again, actually, n plus 1 factorial over n factorial, same thing, will be n plus 1. Okay, so I am used to seeing these situations right now. I have basically a rational function of n. I'm really just going to be worried about what is the highest degree term of n in the numerator and the denominator. So here I notice I'll get an n times n, which is an n squared. On the bottom, I'll get a 2n times 2n. That'll be a 4n squared, which means that my limit will simply be n, the same as if I just computed n squared over 4n squared, which is 1 over 4. Well, that's great because 1 over 4 is less than 1. And the ratio test says if you compute this limit and you get a ratio which is less than 1, then your series converges. So this implies that the original series converges. Now, this is not a geometric series, and so it's not obvious what the series is converging to. Please don't make the mistake of saying it converges to 1/4, which it certainly does not. All right. Well, thank you very much for watching, and I hope you have a wonderful rest of your day.